I'd like to thank everyone for joining us today for our SC21 HPC market update, and I have just a few concluding slides and summary slides. The first is our ROI program, which we've been tracking for a number of years now, and again, we thank DOE for funding the grant and all the initial research for doing this. At this right now point in time, we have 763 successful HPC projects in the database. And if you look at these successful projects, on average, they're generating $507 in revenue per dollar invested in HPC for the projects that are, generating a financial return. And then on the profit or cost saving side, they're generating $47 of profit or cost saving per dollar HPC invested. So it continues to show just phenomenal growth and improvement. And the other thing on the scientific side, the average cost as far as HPC that's invested per innovation is running 2.6 million. So there's just a tremendous number of financial examples and scientific innovation examples in the whole study. Now, I always like to recommend everyone, this is economic analysis that's based on looking at a certain set of inputs and a certain set of outputs, and it ignores everything in between there, as far as, factories, sales forces, accounting and everything else. This is a standard way of looking at ROI. And to make it entirely transparent to the community, the entire data set can be downloaded at the website pointer here. And people can apply their own algorithms or their oon math. If you have an economist on board that says, no, I really think it should be calculated in this fashion, we're providing the entire raw data set. So in addition to doing the economic analysis, this program is about collecting the core raw data. Our hope is going forward in this research area is that we now have enough of the raw data as a starting point. We can now start doing an assessment model for an HPC system itself or an entire data center. And so that's what we're looking to do in the near future. The other topics I'd like to just spend a minute on is, what are the changes in the key buying requirements and inhibitors for on-prem HPC systems? Now, price is always the number one, and whether it's price itself, price performance, or raw performance, those are always the top attributes here. So I kind of look at the ones underneath it. The amazing part is security has moved up to being number 3, pretty much tied with faster CPUs. And then AI and big data capability is now a key buying requirement at 22% of all sites around the world. So just tremendous changes here as far as priority. Now, what are the barriers for buying more on-prem? And again, much like the other side, financial barriers as far as budgets, having money and everything, it's always number one. But power and cooling now has moved up to being a number one criteria at 43% of all sites. This is a substantial change over the last few years. And then along with the scaling and size of the system, space limitations have moved up dramatically. So after those items, if you look at the next 4 or 5 items here, they're all related to a major issue in the industry, and is that the expertise, the HPC population of talent, skills, and everything like that is dwindling. It is shrinking away. People are retiring out much faster than people are joining the industry itself. So one advice we always give vendors or people thinking about starting a business or anything else is making every aspect of the system easier to use so that people don't have to be, PhD class experts just to make use of the systems. The ease of use making is on the software side, the hardware side, installing, but of course running, getting performance and tuning and everything else. But major shifts we're seeing here. And so in conclusion, we originally were expecting the pandemic to impact 2020 by about 7 to 8% in decline, but Fugaku made it a growth year, which we're very pleased with. We do expect that 2021 will be a similar flat year, maybe up a hair bit, maybe down a little bit. From 2022 to 2024, we think everything gets back to a fairly strong growth year. That's driven, as I've mentioned before, by exascale, but also AI, HPD data are just hot growth areas. And HPC in the cloud also is to be growing at an entirely different growth rate. So when you add together the on-prem spending and the spending in the cloud as a whole, as you've seen in our previous charts, just tremendous growth there. The exciting part too in the market these days is all the new technologies that are showing up in all different areas, whether it's new types of processors, accelerators, AI hardware and software, big data things, but new algorithms, new memory approaches, new storage approaches, and then integration of major things like on-prem with the cloud to optimize how you're doing, and then going all the way outward to IoT devices and incorporating that into simulations. So just tremendous new change and complexity, unfortunately, for everyone. The cloud has become a viable option for a number of HPC workloads, a number of sites. We do expect that to continue to grow. And we're watching very closely the rate of growth of spending money in the cloud versus on-prem, and will one affect the other, and so on. And that's something we're studying on a quarterly basis. And storage will likely see major growth, as we mentioned before, driven heavily by the traditional modeling and simulation, especially with exascale machines becoming so large in the higher end of the market, just doing a lot larger traditional modeling simulation. And then you layer on top of that AI, machine learning, deep learning, big data. We expect to see just radically larger data sets in the market requiring a lot more storage. And with that, we'd like to thank everyone for joining us today. And I'd also like to invite everyone to do a short survey. If you go to the navigation menu, you can download the survey or do the survey very quickly. And we do take it very seriously to help improve the way we do our presentations, our briefings, and that. So thank you for joining us today. We appreciate it.